All right, in 6.2, we're going to start verifying identities. And when we verify them, we actually have an equal sign that it's kind of our goal. We move one side of the equation to look like the other. So it helps a lot as we move along to know when you're done, basically. So here are some guidelines to help you through, and then it'll make sense the more you do these that these are the things you would want to do. Okay, you work on one side of the equation at a time. Look for opportunities like factoring, adding fractions with a common denominator, square a binomial, or create a one-term denominator, possible. Look for opportunities to use identities off your chart. When none of these work, sometimes it's best just to convert everything to sines and cosines. But whatever you do, always try something because there's lots of partial credit on these. Even if you get stuck, being stuck and giving me 3 or 4 steps is better than leaving it blank, trust me. All right, so using our charts, let's think about these first ones, okay? Secant of y cosine of y equals 1. Well, I'm going to use a reciprocal property. Secant is just the 1 over cosine of y times the cosine of y. And then it should be obvious to you. These two will cancel out, so 1 equals 1, and I'm done. That's it. Moving on to number 2. Sine squared t over tangent. Now, I know on my chart that tangent t is sine of t over cosine t. It's one of those quotient properties. Well, the same is true even if you square everything. So sine squared is the same as, tangent squared is the same as sine squared t over cosine squared t. Now, when we do fractions, remember, we keep it, change it, flip it. So that would be sine squared t over 1 times, when I flip this, it becomes cosine squared t over the sine squared t. Then these will cancel out, and I am left with cosine squared t. Check the right side. That's what I wanted, so this is where I stopped. I like verifying better than simplifying because you kind of know where you to go and when to stop, right? All right, let's move on to number 3 here. All right, looks a little more complicated. You want to go on the complicated side of the equation. That's really because you have more to work with, really. So cotangent and cosecant squared. But notice on the right, all I have is cosecant. So I want to replace that cotangent with something to get me to cosecant. So one of your Pythagoreans has cotangent squared and cosecant squared. And when you solve for cotangent squared, in this case beta, it would be cosecant squared beta minus 1. So I can just plug that in instead of cotangent. So I'm going to do cosecant squared beta minus 1 plus cosecant squared beta. Let's see what we get. Well, cosecant squared plus cosecant squared gives me 2 cosecant squared betas, and then I have a negative 1, and that's what I wanted on the right, so we're done. Let's look at number 4. This looks complicated, eh? Not so much. Let's keep going. Let's not give up. Now, sine squared. Notice that sine isn't on the right side anymore, so we need to replace it with something with cosine. Well, one of your Pythagoreans, remember, is sine squared of x and cosine squared x equals 1. So I can play with this and replace sine squared with 1 minus cosine squared x. All right, those are equivalent. So I can plug that in right here. So I'm going to have 3 plus 1 minus cosine squared of z. Let's see where that leaves us. All right, drop the parentheses. So 3 plus 1 minus cosine squared z. That gives me the 4. That would be a z. Just terrible looking z. And now it looks just like the right side, so I'm done. All right, this one looks kind of gnarly, doesn't it? This looks gnarly. So we're not looking on page 490, we're looking at your formula chart. So if you look on your formula chart, you have this section called cofunction identities, and they look really gross, right? But they're really helpful because look, this equation, cosine of pi over 2 minus x, let's find that. Well, over here it's in u terms right here. It's just equal to sine. That makes it way much easier, right? We just replace it with sine. So let's start by doing that. We're going to replace that numerator with the sine of, in this case, x. Well, then let's do the same thing with sine pi over 2 over x. So minus x, that would be this, and we replace it with cosine. So it makes it much, much simpler. And we know from our quotient identities that sine over cosine is the tangent of x, and then we're done. So it went from being really gross to not so bad. Now let's see. We don't need these anymore. Let's come over to number 6. Okay, this looks gross, right? But let's just use what we know about factoring to help us out. In fact, there's 2 ways we can solve this. So I'm going to solve it both ways just for fun and see where we end up. All right? Now, first thing you might try is distributing, right? Let's try distributing. So if I distribute both to both terms, I would have the secant to the 7th power of x times tangent of x, okay, minus, now let's distribute this one, secant, that would make it to the 5th power of x times the tangent x. Okay, not terrible, but can we now factor some more stuff out? Well, our goal is to make it easier, right? We have secant to the 7th, secant to the 5th. We can take out secant to the 5th and tangent, can't we? Oh, to the 5th, not 2nd. And tangent out of both terms. That would leave me secant squared x minus 1. All right. Well, this goes to one of our Pythagoreans that we can solve, and it'll say tangent squared x is secant squared x minus 1. So I can replace this with tangent squared x. So I have secant squared x times tangent times tangent squared x. What does that clean up to? Secant, oh, this is to the 5th, isn't it? I'm sorry, to the 5th. Secant to the 5th of x times the tangent to the 3rd of x. And that is what I wanted. That's where I wanted to end up. Now, that's one way to do it. It's not the only way. All right, let's try it another way. Let's try it by, I'm going to rewrite the question really quick. Okay, there it is, rewritten. Now, what can I do here? Well, some of you may just recognize, hey, don't they have just these in common? Can't I just take that out and regroup them? Sure, you can do it that way. So what happens next? So we'd have secant x tangent x. What's left over would be secant to the 6th of x minus secant to the 4th of x. All right. Now what can we do? Well, we can do a GCF on these two because you can take a secant to the 4th out of both, right? So I'm just going to move this over. And I'm going to factor out secant to the 4th of x out of these two terms. And that gives me secant squared x minus 1. And here we are again with that Pythagorean, right? We can just replace. So I have the secant of x times the tangent of x times secant to the 4th of x times tangent squared of x. All right, let's put it all together. Secant x times secant x, that would give me secant to the 5th of x. Tangent times tangent squared gives me tangent cubed of x. So there's my answer, all worked out. So either way is good. Either way is legit. You can do this, and both are correct. You just got to show me your steps. And if you get, like I said, if you get stuck, do not stop. Just keep going, and I can give you partial credit if you're going the right way and maybe help you get unstuck. All right? So I enjoy verifying identities. I hope you are enjoying it. It's just a puzzle that we work out with all the clues we've been given.